I'm recording, so this lecture will come up. Okay, so in the last class we have seen the form. Okay, this is basically called the Legendre function, and we basically have it in the form as Pnx is equal to 1 divided by factorial n 2 to the power n dn dxn x square minus 1 to the power n, and this is actually called the Rodriguez formula. So if I want to find out, let's say p1x, p2x and so on, I'm not replacing x, I'm just finding out the function. Okay, function. So I'm finding out the functional form of this. Okay, so in general, if I just want to find out the function, okay, this is just an example that we need to remember. We are going to take up problems later. So let's say I want to find out p1x. Okay, this will be a function of x. So what I'll do is I'll simply put, n is equal to 1 in the Rodriguez formula. So if we do that, we can say that this is p1x. Okay, and this is 1 divided by factorial n, so this will be factorial 1, okay, into 2 to the power 1, and then this will be only a first order differential equation, so dn dxn, so d1 dx1, okay, these are all 1 here, okay, into x square minus 1 to the power 1. Okay, so if we do it, this is 2, this is d dx, so x square is 2x, 2 gets cancelled, I get just x. Okay, so in a similar way we can actually find out p2x also, and so on. So these results can be found out. Okay, these are applicable when we actually need to know a function for a particular value of n, let's say. So this will be this will be 2 square, and then this would be d square dx square, this is x square minus 1 square is equal to, right? So if you take this is 2 square is 4, 1 divided by 8, okay, and then this is d dx of, let me differentiate it once, so this is 2 times of x square minus 1 to the power 2 minus 1 is 1 into 2x, right? So we can do it. So this 8 will get cancelled with these 2 and this 2, so this will be 2, so I can just simply write it down as half. Okay, and this is x cubed, x into x square is x cubed, so this would be 3x square if I take d dx of that minus of 1, right, because this is x minus x. Okay, so this way you can actually find out. So this may be an objective question, and this straight away tells you that you need to remember Rodriguez formula. That would be very important. Okay, but then let's just get back to Legendre differential equation and try to find out few results which we have used in deriving the Rodriguez formula. We've just done one class on Legendre differential equation. That means we have a lot to cover. So let's just start with something which we call as the generating function. So what do you mean by generating function? You will get it in most of the polynomials. It means that you will basically have a function, okay, it may be of any form, and that function will actually generate that polynomial or that differential equation. So if I say Legendre differential equation and I want to generate that Legendre differential equation, I need to know a function from where I should start. So that starting function is called the generating function. So this word is very much logical to use. So we are going to look into the generating function of Legendre polynomial. Okay, so before that, Legendre equation, let me just write it down once again. Legendre equation. Okay, and what's my Legendre equation? What my Legendre equation is 1 minus x square. All these are differential equations of second order. Okay, because we have seen in our syllabus also, when we actually started with this unit, we started solving differential equation of second order. So we should be very much comfortable with solving such differential equations, and based on that we are solving these polynomial problems. So n into n plus 1 into y is equal to 0. Okay, so this is your Legendre equation, and if you just want to look into the solution of such equations, you actually can have these forms: a p n x, okay, b q n x. It will depend on what's the form, but in general general solution may be something like this. Okay, and then we have written f p n x. Okay, So if we just go back to go back here, let's say, okay, check this. Okay, 1 divided by factorial n and then 2 to the power n, and then we can differentiate this n times x square minus 1 to the power n. Okay, and then so on, and then that way we can actually get different forms of Pn also. Okay, so we're going to just look into that later. Okay, let me just okay, Pnx, maybe we can just come to that later. Okay, let me just do some problems first. So this is the beginning of the generating function. Okay, let me write down the next problem in the question format so that it's comfortable. The question is to show that, okay, we'll do it slowly, please get a proper understanding of this. Pnx is coefficient of z to the power n in expansion of what? That means that is our generating function. Okay, so when we actually expand this xz plus z square to the power minus half, this is x. Okay, this is 1 minus 2 xz plus z square whole thing to the power minus half. Okay, and this is actually the function which will actually generate the polynomial. So there can be different ways of asking this question, and just complete the question in ascending power of x. Okay. So that may be a question, or maybe a question would be something like this, or show that, okay, or show that I'll just give you the result that we are finally looking for. 1 minus 2xz plus z square whole thing to the power minus half is equal to summation n is equal to 0 to infinity. This is a series, right? So we can write it that way, z to the power n, then we'll have the function Pnx. So you can write down a function in fx also, but you know it's Bessel function, so we represent it in a certain way. It's a generating function, I mean it's a Legendre function, we're representing it by Pnx and so on. Okay, so it's just a way to represent it, there is no confusion there. Okay, it's quite simple. Okay, so let's try to prove this. Okay, let's try proving this. So for proof, obviously we need to start with an expression, and this expression is this. Just be careful, look into the steps here. Okay, is equal to, so let's start with, let's say 1 minus, I can take z common here, then I can write it down as 2x minus z whole thing to the power minus half, right? This is an expression that I can write, and now what I can do is I can expand this. I can use the expansion here. This is to the power minus half, so this is minus, there is a minus here, there is a minus here, so the summing up terms, everything will become plus. So this is important, let's write it down carefully. So it will be 1 plus, and this half will come in front, minus half minus minus will become plus, into z is already there, and then it is 2x minus z. Okay, that's the first term we have, plus, if you recall this expansion, you can write down all the odd terms here, and we will basically have the all the even terms at the bottom. So this will be 2 4 into z square. These are series expansions. Okay, you have to please recall this, which is very important. So I'll square up the other term, the powers will keep on increasing, right? And in that way what I can do is I can keep on writing the term. Let me write down the second last term, the penultimate term. The penultimate term would be something like this. Let me write down the numerator first. It's 1 3, and it will keep on continuing, and let's say the final term is 2n minus 1, because it's not even, it's all the odd terms. So 2n minus 1 would be the final term, so that means the term before that would be 2n minus 3. This will always be an odd term. At the denominator it will be 2, 4, and so on, and then the term would be nothing but 2n minus 2. So this will be the even term that we'll have, right? And then we can have z. So you see this is 0, okay, then we have got 1, then we have got 2, so it will basically just continue and it will be up to z to the power n. So z to the power n, that means the term before that would be z to the power n minus 1, okay, and finally we can just write it down as 2x minus z whole thing to the power n minus 1. So this is square, this is square, so that means the final term would be n, term before that would be n minus 1. There is a reason why I've written it with the n minus 1 term, and the final term would be something like this: 1, 3, then keep on writing this, and this would be 2n minus 1. That would be the odd term, and then this would be 2, 4, and this would be 2n, right? That is the final term. Then this would be nothing but z to the power n. Write it down very carefully, and then this would be 2x minus z to the power n. So this is my expansion for this, right? If I expand this, I'm going to get this term, okay? So let's just let me just copy this and take it to the next page, otherwise we cannot keep a track, it's a bit difficult. Okay, let me copy everything here. Okay, you don't really need the first slide, check the second line now. Okay, so we have this expression now, and now what I want to do is I want to equate the coefficient of z to the power n, okay? So the next step is coefficient of so there are terms here where you can actually find out what are the coefficients of z to the power n, okay? Let's check this last term, okay, of z to the power n, okay, last term, let's say the last term. It's simple. If we check this, this is z to the power n, that means everything else is the coefficient of z to the power n. So what you can do is this, so check here, this is 2x minus z. So if you expand this, okay, if you expand this expression, you will get a term as 2x whole thing to the power n, okay, and then you can write down this as n and then c1 combination, permutation combination, if you remember, this would be 2x minus 1, okay, to the power n minus 1 into z to the power 1, and so on. It will keep on continuing. There is already a z to the power n here, so if I take this second term, this would be z to the power n minus 1. So that means this term is actually not needed, we just need this term, the first term. So if we expand this, you get a term of 2 to the power x, 2x to the power n. So that means if we expand this and we want the coefficient of z to the power n, we need to get rid of all the other terms because we don't need it, we just need 2x to the power n. So I will take out 2x to the power n from here, multiplied by zn will be actually giving me the coefficient of z to the power n, and then we have got these terms, okay? So that means I can just simply write it down, 2x to the power n into 1 into 3 into 2n minus 3. Look into it very carefully, it's very basic, but the thing is it's a bit long, so you have to take care when you do your expansions. 2n minus 2, done. Once we have this, we can actually try to simplify it. How? I can just write it down as 2 to the power n and x to the power n, and at the denominator, you see, you can take out 2 common here, and then there will be 1 2 from here, 1 2 will be from here, and here you can again take out 2 common, okay, which is the nth term, you can say, and this inside bracket it will be nothing but n minus 1, okay? So how many terms will be there, you have to just take care of that, okay? So if I just take a bracket here, okay, this would be, 1, 2, it will go up to n. Okay, take this. Okay, understand this. This is important. And what you can do here is even more to simplify it. Okay, just a moment. mm, this was the last term, right? This was the last term, so this is not 2n minus 2, sorry. I'm talking about the last term here. I'm talking about this term, so this is not 2n minus 2, this is just 2n. So this is just
There
2n.
is 2n minus 1 also.
2n minus 1 will be here. Okay, here. Oh yeah, on the top it is 2n minus 1, right? I have just written the
Yes.
second last term, sorry. I made that mistake. Yeah, this is 2n minus 1, correct. So you have got 2n, 2, 4. You could take out 1, 2 from here, 1, 2 from here. There are n terms. Okay, that means I can take out n number of 2's from here. So it is 2 to the power n, which can be taken out, and then I will have this series here. Okay, and at the denominator, I'm not going to change much. I'm going to just keep it like this: 1, 3, and then it is 2n minus 1. So that means this 2 to the power n, this 2 to the power n will get cancelled out, and finally what I have is 1, 3, and then 2n minus 1 divided by, this is 1, 2, 3 up to n, that means it is factorial n, so I'll write it down as factorial n into x to the power n. So this is the coefficient of Zn from the last term. If you look into the second last term, there also you are actually going to get a coefficient of Zn. Okay, so let's just do it. Okay, coefficient of Zn, coefficient of Zn. Okay, maybe I can write down second last term or penultimate term. I'm just writing it down like this. You can also write down the entire term and then find out the answer. Okay, so this is a bit tricky. Let's just write down the coefficient first. We are talking about this one now, the second last term. Let's see what we are getting here. So this is 1, 3, and then this is 2n minus 3. At the denominator it is 2, 4, and then this is 2n minus 2. Okay, so we have this term. Now if you look at the denominator, okay, and let's check out this. Okay, maybe I should explain it a bit better. It's very confusing else. Let's look into this particular term. Okay, so if you just write it down as z to the power n minus 1 into 2x minus z to the power n minus 1. Okay, can we expand it? Yes, we can just write down z n minus 1, and let's just expand this particular term. So the first term would be nothing but 2x n minus 1 into z to the power 0, so that's there. Okay, so it's only 1 into, oh sorry, minus, because there is a minus sign there, so it will be minus of n minus 1. The term would be c1, which is combination 1, which is nothing but 1. Okay, if you remember, and then I will take the increasing power of z and the decreasing power of 2x n minus 2, and so on. So I'm not going to write down the later term because we don't need it. So check here, the first term I'm going to get zn minus 1 if I multiply, but I need the coefficient of zn, not zn minus 1. So if I now multiply zn minus 1 with z1, I will get that coefficient of zn, right? So that means I have got the term as zn minus 1, 2x to the power n minus 1. The next term here, c1 is 1. So I'll get z n minus 1 into z1. I'll do it later. So I'll just write down the coefficient. This will be n minus 1. c1 is 1. I don't write it down. And then this would be 2x to the power n minus 2 into z, into z to the power n. So that means this is my coefficient from here, right? So that I can actually write it down. So we have to be very careful about this. And then there is a minus sign. So this minus sign also I have to include in the coefficient. So I'll just put a bracket to keep things easy. And within bracket it will be minus of n minus 1 into 2x to the power n minus 2. So you see, from the second last term also actually I'm getting a coefficient of z to the power n. Okay, let's try to simplify this a bit. Okay, let's go to the next page. I think I'll need some space here. So just remember this, minus n minus 1 2x to the power n minus 2. I'm not going to copy it. I think it's not very complicated. पेज ले लेते हैं यहाँ पे. Okay, so I write it down as equal to, I have a minus sign, so I'll just put that minus sign in front. so that I remember it every time I do it. So it will be 1 3. Let me just write down as much as I can here. 2n minus 3 divided by 2 4 2n minus 2, we have it here, right? And then we have got an n minus 1 term here, and then we have got 2x to the power n minus 2. So let me write it down as n minus 2 x to the power n minus 2. Okay, so we have up to this term. Now the thing is, what we can do is this. See, this is 2n minus 2 here. Okay, they have got 2n minus 3 here. We can actually take out 2 common here, and we can see how many terms we are actually getting rid of. So you see, if I take 2 out common, it will be n minus 1. That means there are n minus 1 terms. But here we have the power is 2n minus 2. That means what I can do is this. I can take a 2n minus 1, and I can also divide it with 2n minus 1. I'll tell you why. Okay, we'll check in the next step. I'll multiply and divide, and I'll also multiply and divide with n, because if I take common, I get n minus 1. I don't get n term. I can take this n and make it as factorial. Okay, let's do it first, and then I think it will be more clear. So let me just write down here. Let me just put the minus here, and then this will be 1 3. Careful while doing, okay, because we should take some time to understand this. It's confusing. So if you take 2 out here, it will be 1, 2 out here, it will be 2, so it will be 1 2 3 4 5 6 and so on, up to you take out 2 here, it will be n minus 1. So that means you have taken n minus 1 2's out. So you can take out 2 to the power n minus 1 common, and within bracket it will be 1 2 and so on. So it will be n minus 1, right? Okay, now take a look at this. This is 2 to the power n minus 2. Okay, so maybe let me just modify this once, and then maybe we can easily do it. Okay, so I can take one n inside this n. I can actually take it inside. Okay, so I will take this n inside rather. So you know from where this n is coming. Okay, and what are we left out with? Let's just check it once. We are left out with n minus 1. Okay, n minus 1 and 2 to the power n minus 2. We are left out with that. Okay, and then we have got something which is x to the power n minus 2. Okay, and we have 1 2 n minus 1, right? So I think I'm getting a bit confused. Yeah, this is 2n minus 1. So here with this, after this term, okay, after this term, I'll just take this space, 2n minus 1 also I can write it down. So I have combined it here. Okay, that means at the denominator I should be left out with uh, this one. I have to adjust. So that means I can take this as 2, okay, into 2n minus 1. Okay, why? Because if we check this, okay, just a moment, I think there is some mixing up here. This one was n minus 2, so 2 to the power n minus 2, f to n minus 2. This is n by n. Okay, this is 2 to the power n minus 2 divided by 2 to the, yeah, this is correct. So if I write down a 2 here, if I write down this 2 here, I can modify this and write it down as 2n minus 2, because 2n minus 2 can be written as, this 2 can be written as 2 to the power n minus 1 into 2 to the power minus 1. So this 2 to the power minus 1 and 2 to the power minus 1 will actually get cancelled, and I will get back 2 to the power n minus 1. So please be very careful here. It is 2 to the power n minus 1, no problem. I have added additional 2, divided it by 2 and multiplied it by 2 here, so that I get 2n minus 2. What I want to do is, I want to cancel this out. So this way I can cancel this, and I can cancel this. So I can cancel these two terms out. Where do I get this 2n minus 1? Because this 2n minus 1 and this 2n minus 1 gets adjusted here. Okay, what about n? I have my n here already. Okay, and then we have got n minus 1 here. So that means I missed out another n. So one n should be there at the denominator. Yeah, now it's correct. Okay, so we've got rid of this. That means at the denominator we have actually got a factorial term. Okay, so let's just write it down again now. So this would be minus 1 3, and then we have the term up to 2n minus 1 divided by, this is factorial n, this entire term is now actually factorial n. Okay, and then we have got a term of 2 to the power n minus 2, right? Did I miss that term also? Yeah, no, this is there. 2 to the power n minus 2, that is already there, so we have already cancelled it out. Okay, and then we are left out with n, and then n minus 1 divided by 2 into 2n minus 1 into x to the power n minus 2. Okay, so this is the term that we have. So you see, you have to do some adjustments here so that you actually get the term which is something similar to the coefficient of z to the power n of the last term. See, this is something similar here. Okay, we are also see, this is similar. The next term actually gets changed here, so these terms are getting changed every step. So this way we can actually keep on doing it. Okay, and so on and so on. What do I mean by this? It means that I have done the last term, I have found out the coefficient of z to the power n in the second last term, and then I can keep on doing it. Okay, so that means we can actually find out the coefficient of z to the power n. Okay, so therefore coefficient of z to the power n, okay, in expansion of what, 1 minus 2xz plus z square whole thing to the power minus half, okay, is equal to 1 3, and then 2n minus 1. This is common. Okay, both the terms we see everywhere, it will find out common. You adjust it accordingly, you are going to get it. And then this would be x to the power n, that was for the last term, and this is the second last term, so I'll take plus n into n minus 1 divided by 2 into 2n minus 1 into x to the power n minus 2 plus, and so on. I'm not going to write down the remaining term. This is actually the Legendre function or Rodrigues polynomial. So this is actually written as Pnx. Okay, what does this conclude? Let me just write down some lines here. So that means what we can say is we find, so you know, if someone tells you find out what is Pnx, Rodrigues formula is obviously there, but if you want to take this generating function and find out the Pnx from there, you have to do it in this way, because Pnx will give you the coefficient of all the z to the power n added together. Okay, so we can say we find that P1x, Pnx, remember, so P1, P2x and so on will be coefficient of what, z to the power 1, z square and so on. Okay, in the expansion of this. So please remember this function, which is very important. That's the legend in Legendre polynomial, very important, this function. Okay, so basically keep on doing this. So please remember there is a difference between P1x, you are talking about the term number, and there is a difference between P and 1. Here you are actually talking about the coefficient or the variable x, which you are replacing it with some constant value. Okay, so there is a difference between these two, don't mix it up. Okay, so that means we can say that therefore 1 minus 2zx plus z square whole thing to the power minus half is equal to 1 plus z p1x plus z p2x, and whatever value we found out. Okay, let me just show this to you once. Whatever value you found out, if we just put in 1 in place of n, you are actually going to get your p1x, p2x and so on. Okay, in place of n, so please remember that. So if you do it and multiply it with z, okay, and then maybe z2, okay, and so on, sorry, it's not z2, z square, right, z square, and then so on, I can just keep on multiplying this. This is z to the power n p n x. So if you keep doing it, you are going to get the result, and then finally you can just put a summation n is equal to 0 to infinity. This is z to the power n p n x. Okay, this is what we are actually finding out. So the thing is, you have to take a function which is the generating function, and from there you have to generate p n x, which will be the coefficient of z to the power n. Okay, if you look into the Rodriguez formula and compare both of them, you are actually going to see that you are going to arrive at the same result. We are going to look into that. Okay, but then that is very important that you need to understand this one first. So this is the generating function of Legendre polynomial. So your question might be, whatever I've shown, show that this is equal to this. Okay, or maybe show that p n x is a coefficient of z to the power n in the expansion of this. So you expand this, the coefficient of z to the power n would be p n x. What is p n x? Forget about Rodriguez formula. If you want to just know what is p n x, this is, okay, this is your p n x. So you have to find out what is the coefficient of z to the power n, and then the coefficient of z to the power n in the penultimate term, and then you have to just do 2. Now in exam, I know some of you will do it. Okay, many people does do it. Finding out the coefficient of z to the power n for the last term is easy. Okay, but if you are in a hurry, if you don't have much time, you make a lot of mistakes in finding out the coefficient of z to the power n in the second last term. But please remember, when you write down in your exam, if you just write down the coefficient of z to the power n in the last term, and then you don't find out for the second last term and directly write down this, your marks will get deducted. Okay, because it's important that you understand the problem. So you have to do your adjustments accordingly here. It's not very complicated. You have to just remember that whatever was the coefficient of x to the power n in this term, you have to get that result from here. So for that you have to do certain adjustments. First adjustment would be 2n minus n1 divided by 2n minus 1, and the second one would be n divided by n. And bring it here, you get it as factorial n, and 2n minus 1, you get it here, you get the same term. And the remaining term will remain as it is, except you have to remember that you have to cancel out this 2 to the power n minus 2 term. That's it. Once you do it, it should not be difficult. Okay, you'll be getting it. Even if you don't cancel it out, it's still fine. So you get 2 to the power n minus 1, right? Even if you don't cancel it out, it's still fine. You get at the denominator 2 to the power n minus 1, okay, and on the numerator you will have this term anyway, 2 to the power n minus 2. It's already there. So if you just combine them, you'll get it as 2 to the power n minus 2, okay, minus n plus 1. So this n will get cancelled. So this is 2 to the power minus 1. This is going to be half. So even if you don't include that 2, it's fine. You just calculate it. You are going to get it to be 2 to the power minus 1 only, or 1 by 2. So anyway you do it, you are going to get the same result. So just keep it simple. That's it. Don't complicate things. That's very important. Okay. Let me just finish with one thing here, which is important. We have done it in the last class. We have used this result last class. This may be a 2 marks question, and let me just show you how it is. So last class we actually proved Rodriguez formula, and there we actually have shown or used this result. Show that Pn1 is equal to 1. The question is how. Okay, let's just do it. So here we are going to use this generating function result. So we have got 1 minus 2xz plus z square to the power minus half is equal to summation is equal to 0 to infinity z to the power n p n x. So you have to find out what is pn1. That means you have to replace x with 1, and then you have to just find out what is the coefficient of z to the power n on both sides, and that way you can easily do it. Okay, so let's just do it first. Okay, let me just do it. Put x is equal to 1, and if we do it, this would be nothing but 1 minus 2z plus z square whole thing to the power minus half is equal to summation n is equal to 0 to infinity z to the power n p n 1. So you see, you got Pn1 here. You need Pn1. That means Pn1 is the coefficient of z to the power n. That means on this side also I have to find out what is the coefficient of z to the power n. That's it. Okay, that's the aim. So straight away I use some logic and you'll get it. And this one is simple because this is 1 minus z square, right? This is the expansion of 1 minus z square minus half. This 2 and this 2 would get cancelled. So this would be nothing but, okay, I have to repeat this again, infinity z to the power n p n 1. So if we expand this, what is this expansion? This is 1 minus z to the power minus 1. So you remember 1 minus x to the power minus 1, we'll get all pluses here. So it will be 1 plus z plus z square, and then you can keep on going. This would be z to the power n times. This is summation n is equal to 0 to infinity z to the power n pn 1, right? So we can just equate the coefficient of z to the power n. So equating the, please write down the entire term word here, z to the power n. You see this side it's 1, z to the power n coefficient is 1, here on this side this pn 1, right? Proved. So that's how you prove this result. Hardly 2 marks question, not a descriptive question. Okay, so this is important. We are not yet over with Legendre Polynomial. Okay, let me see if I get one short problem which I can solve at least for today's class. Okay, yeah, I have one. Okay, let me just solve one more problem here, because it's better to complete as much as possible. Okay, let's take one more sum. Here also we are going to adjust the coefficients here. Prove that Pn, this is minus x, so in place of x we are going to put minus x, is equal to minus 1 to the power n Pn x. Okay, so let's see how we can actually prove it. Okay, so proof, we'll start with the same thing here. Okay, 1 minus 2xz plus z square whole thing to the power minus half is equal to summation n is equal to 0 to infinity z to the power n pn x. Okay, and then we will put x is equal to minus x, so that way we can get on this side, this is 1 plus 2xz plus z square whole thing to the power minus half is equal to summation n is equal to 0 to infinity, nothing to do with z, nothing to do with n, the only thing that we need to change is x to minus x. So I've done it. So you see pn minus x, pn minus x. So that means here also I have to equate the coefficient of z to the power n. Okay, so we are going to do it in two steps. So first thing is this. In the next step we are going to say put z is equal to minus z. You will understand why we are doing this. So if I do it on the right hand side, on the left hand side it will be 1 plus 2xz. In place of z we are putting it as minus z. Okay, so this is minus z, so this is plus, and z square minus z square will remain the same, so this is there, z square minus half. So you see the left hand side remains the same, the right hand side is definitely going to change here. N is equal to 0 to infinity, this is z to the power n, so that means if I write it down as minus z to the power n, I can simply write it down as minus 1 to the power n into z to the power n into Pn of x. Okay, so we have got these two terms. Okay, so let me mark this as number 1, mark this as number 2. Don't get confused, we are putting z is minus z in this equation, not in this equation, so it is x, it's here x. Okay, so don't get confused here. Okay, so what you can say, therefore from 1 and 2 we have this side is the same, so this side we can equate. So let me just take minus term on one side, infinity minus x term, z to the power n p to the power n minus x is equal to summation n is equal to 0 to infinity minus 1 to the power n z to the power n pn x. See, got it, right? Therefore equating coefficient of z to the power n on both sides. So you see on this side z to the power n is this, so that means this is p n minus of x is equal to, on this side, z to the power n coefficient is minus 1 to the power n p n x. Proved. So these are 2 marks question. Okay, you have to just remember the generating function term, and then you have to just take out the coefficient of z to the power n, and you can solve it.